can't jump in and finesse. It don't make no sense.
Hello. Today we're going to be talking about identification numbers. So what's a code? A code distinguishes one product from another.
A check digit is the last number in an identification sequence. In this example, number 2 would be the check digit because it is at the end. It is used to make sure there are no errors in the identification sequence.
Another error detecting mechanism is the division by 9 schemes. This mechanism is used for 11-digit codes, and it is used by taking the first 10 numbers of the digit and adding them together, and then using the 11th digit as a check number. After adding the first 10 digits, you're going to divide them by 9. And whatever remainder you get should equal your check number. And if it's not, then you can assume that you typed one of the digits in wrong. So if you use this one for example, we add the first digits together and we get 42. After dividing them by 9 using long division, we see that we can only get 9 into 42 4 times and leaving a remainder of 6, which equals our check digit. The division by 7 schemes is kind of like the division by 9, where we divide a number by another number to get a check number, but unlike the division by 9, we use the actual number rather than the sum of its digits. So if we use this number, for example, and divide it by 7, we use long division to get 4, which is our remainder, and that we use that as our check number. But unlike the division by 9, we don't have to include the number 4 into the number. We just assume that it's going to get 4 as a check number.
So now we're going to talk about the Universal Product Code, which also stands for UPC. And basically they're all in all like grocery store products. And this number is broken down into different categories. For example, the first number stands for the broad category of goods. The next 5 numbers identifies the manufacturer. The next 5 numbers identifies the product, while the last number stands for the check digit. So the error mechanism method for this UPC is that what you do is that you multiply every other number by 3. So I multiply this one by 3, this one, this one, this one, this one, this one, and this one by 3. Then you add them all and you get 58. And then you take the check digit, which is the last number, and you add it, and you get 60. If the answer to all of this ends with a 0, it means that it's correct.
Another system used by banks is the bank identification number system. It uses 8 digits, excluding the check digit, and it has weights of 7, 3, and 9. In this example, using all of these numbers, the total sum is 13. So in order to get this ending in 0 or divisible by 10, the check digit would be 7.
Okay, so now we're going to be talking about the International Standard Book Numbers, also known as ISBN. So if you look at your books, and you look at the first page of the book, around the first pages, there's going to be a list of the ISBN numbers that your book represents. So for this example, we're going to be looking specifically at the student edition hardcover ISBNs. So ISBNs, there are 2 different kinds of them. There's the ISBN 13 and then the ISBN 10. So this is how these ISBN numbers are broken down. The first chunk of numbers always represents the language in which the country that it was published speaks. So for example, number 1 always represents English because we speak English here. Then the second chunk of numbers represents the manufacturer. The third chunk of numbers represents the actual book in itself. And then the last number is always your check digit. If you look at the ISBN 13, you're going to notice that there's an extra set of numbers, which is the 978. And what this means is that once they started doing the ISBN 10, they started to see that they were running out of numbers for identification, so they started to add more numbers, and this is just a purpose of identification, even more identification. So now I'm going to teach you how to find the error mechanism for the ISBN numbers, and this is the formula for it. So what you do is that there are 10 different numbers in the ISBN. And what you do is that you take number 10 and you times that by the first number. So in our example would be 1. So 10 times 1. Then you add that to 9, which you times it with our second number, which is 4. Then add that to 8 with our third number, which is 2. 7 with our fourth number, which is 9. And you do that so on until you get to the very last number, which in our example is 3. So 1 times 3. Once you start solving that, you're going to get these numbers. Like for example here, you do 10 times 1, and then you have 10, and then so on. Once you have these numbers, you add them all up, and in this case, we have 184. So once you have this number, you go back to your original check number, and you add that. So 184 plus 3, in this case it's 187. Then you take this number, 187, right here, and you divide it by 11. This is just the rule that these ISBN numbers have. You always have to divide it by 11. So you do 187 divided by 11, and if you get, and in this case you get 17. If you get a whole number, it means that it checks good, and then you're all good to go.
So another system that's used is the Caballero scheme, and it's used for the South Dakota Driver's License Department, many blood banks, libraries, and all the major credit cards. So it's 15 digits long, excluding the check digit, and for this particular example, I'm going to run you through how you'd solve for it. So you multiply every other number by 2, and then you add all of them up, just like in all of the other cases, and you get 28 for this particular example. Now normally you just add the check digit to that and then you'd be done. But for the Caballero scheme, you also have to add every instance where a number that was in the odd position exceeded 4. So there's only one case of that here, with 2 times 4 being 8. So you add the one instance to the final number here and you get 29. Then to get the check digit of 1, well, you get the check digit of 1 because 29 plus 1 equals 30, which is divisible by 10, and it ends in 0.
Zip codes are another form of identification number. They were established in 1963 in order to number every post office in America. They begin at the furthest point at E00601 for Adjuntas, Puerto Rico, and they end at the farthest point, which is 9, for West 99950 for Ketchikan, Alaska. They started with 5 digits, or they are 5 digits, each representing something different. So the first digit represents one of the 10 geographical areas, and each one of the geographical areas has a couple states in it, and then the second numbers, well, the second and third numbers represent and identify the central distribution point. And this is strictly for every zone within every state. So for example, for North Central, we are within the 05 central distribution point, which is for the middle northern part of Illinois. And then the last 2 digits indicate the town or local post office, which for North Central is 40, and that is our local post office.
Multiplication by 13. Suppose there's a situation where a teacher wants to post the grades of the students out on the hallway. However, they don't want other students to know the students' IDs. Well, this is a way that a teacher can handle this situation. So what you do is that you take the last 4 digits of a student ID, and then you multiply that by 13. So you take, for example, this 4856 times 13, and then the answer will be 63,128. And this will be the identification for the student.